So on the last slide, we talked about, or we showed that all a radian is another way to think about, it's another unit of measurement that we're going to be dealing with instead of degrees, okay? Um, and so we have this picture right here, and you've seen this on the other YouTube video that was linked in the slides, but we can show it here. One radian is defined as the measure of the central angle, or of a central angle whose arc length is the same as the radius of a circle. And what we're getting to here, we can actually look at and see its relationship with pi, where we get all of this information. So if I take this piece right here and I duplicate it, and I'll go on ahead and change the color of it so we can see a different piece of it. Okay, we're actually going to try and match this on, so bear with me as I draw that. Okay, we've got one radian being our blue arc. We've got our red arc. We're going to duplicate this again, and we'll change its style, change its color. Okay, and we'll rotate that, and we'll see, does it land pretty close? Not quite. So we've got 3 radians right there, and then if you'll notice, we've got just a little bit. Okay, so the relationship between degrees and radians, if we actually take it all the way around the circle, so we can duplicate this, flip it upside down, and move it all the way around the circle, okay, we have 1 radian, 2 radian, 3 radian, 4 radian, 5 radian, 6 radian, plus a little bit on both ends. That's where 2 pi comes from, okay? 360 degrees equals 2 pi radians all the way around. If we divide both sides by 2, then we get 180 equals pi radians, which we know pi equals 3.14. And I apologize if I'm kind of bouncing around the ideas here, but hopefully by now we can see that 3.14 radians is going to be the distance around the circle in relation to its radius, okay? So this radius right here is the same distance. Basically, think of it like a piece of spaghetti. If I had like a cooked piece of spaghetti, not a firm piece of spaghetti, but if I had a cooked piece of spaghetti and I removed it from the radius, okay, and then I transferred it to the arc and I just laid it on top, it would land where that blue arc is. And then we could duplicate that around the circle, okay, to get our 3.14 radians going halfway around the circle, and then going all the way around the circle, getting to 2 pi radians. All right. So it's just another way, just like miles and kilometers, we can use some conversion factors to go back and forth between the two. And that's actually what we're going to do right here. Okay. We're going to convert between degrees and radians, or radians and degrees, by taking our degrees. So degrees right here is going to be 45. We're going to multiply that by pi over 180 degrees. And all we're going to do is we're going to treat this, we're just going to multiply across and then simplify down, okay? So a couple different ways to think about that. You could multiply it across right now, 45 degrees times pi over 180 degrees. We know that our degrees are going to cancel out because they're the same on top and bottom. And then we need a number that goes into 45 and 180, or we could just divide, 180 by 45, and we're going to get 4. So if I divide 45 by 45, I get 1, and if I divide 180 by 45, I get 4. So this is going to be pi over 180, actually, sorry, pi over 4 radians is going to be my answer, okay? I could do 45 divided by 180 and then math frac that to get my fraction. And these are going to be much preferred in fraction because of the pi, okay? So we're going to mess with it over here, doing kind of the same thing. Pi over 180 degrees, that equals 135 degrees over pi, over 180 degrees. And then we're going to cancel out those degrees. 135 divided by 180, math frac. We end up with 3 pi over 4 radians. And you might see that simplified as rads instead of radians. I can't cancel out that pi because there's nothing to cancel it out with on bottom, so we leave that pi, and that's actually going to stay in our answer because, and we'll show what it looks like, pi divided by 4 or 3 pi divided by 4. Those aren't very pretty. Those are technically the decimal answers, but that's kind of why we prefer to leave it in fraction form. It's a much cleaner look. I can make a lot more sense out of pi over 4 radians as opposed to 0.785398, okay? It's just a little bit easier to see. Same idea when we're converting radians to degrees, okay? So over here, we have radians on the left, and so because we're going to degrees, we need to cancel out our pi, so that's why we have to have pi on bottom, and because we know that 180 degrees equals pi, 180 goes on top. So we end up with this 8 times 180 times pi over 3 times pi. Our pi's cancel out, okay? And then I can do some manipulation. You can simplify first or multiply and then divide, however you want to do it, okay? I personally know that 180 divided by 3 is 60, so I can multiply 60 times 8. But if I wanted to do it the long way, okay, I could. 8 times 180 equals 1440 divided by 3 equals 480, all right? So this would just be 480 degrees because we are left with degrees on top, okay? Like I said, if I did 180 divided by 3 and then multiplied that by 8, I would also get 480. So either way you want to go to get there, we're going to do the same thing over here, 180 degrees over pi. So that's going to equal 3 times 180 degrees times pi over 4 times pi. My pi's cancel out, so I'm left with 3 times 180. Divide that by 4. I get 135, and I am left with that degree symbol, and so that would be my final answer.